Hello, Bronx Middle School Math. We are back at it again with lesson 5. And in this lesson, we're going to be doing to the power of tens, figuring out what that is and getting some practice on how to do it. Okay, scholars, I have been very generous. In lesson 1, 2, 3, and 4, I have been saying 0.75 or 0.123. We are not doing that anymore. I was using this and saying that so that we would adjust, feel comfortable with decimals because decimals can be intimidating, but no longer. That is it. We are taking away the pacifier. No more comfort blanket. We are not going to be saying 0.75 or 0.123 anymore. We are going to say 75 hundredths, 123 thousandths. Now that y'all are comfortable with decimals, we need to get comfortable with saying the proper name. So this is 75 hundredths, and as a fraction, it would be 75 over 100. And this next one is 123 thousandths. That would be 123 over 1,000. So I want y'all to be comfortable with saying the proper name and being able to translate it into fractions. So no more 0.75. We are saying 75 hundredths. We have graduated from the rudimentary names. We are moving on up. So we started today's lesson with a you teach me. So in class, I had the scholars tell me what is place value, describe a number line, and how do we round decimals. So we were letting, the students raise their hands and teach me. So the main points that we made is that when you want to increase a place value, you multiply it. And multiplying by 10 increases one place value. And then if you want to decrease your place value, you do the opposite of multiplication. You divide. So let's say I have 7. 7 is in the ones place. If I multiply by 10, that's going to increase my place value. It's going to then become 70. But what if I divided by 10? If I divided by 10 instead, I would end up with 7/10. You see, I almost said 0.7, but I keep my word. We are not doing that anymore. Now we have 7/10. Well, if I were to, instead of divide it by 10, but divide it by 100, I would end up with 7 hundredths. But look at this. I want y'all to notice this. So let me back up a bit. And let's say my number is 7/10 and I divide it by 10. That would move me one place value to the right, making it 7 hundredths. So it's about where you are. Where do you start? So divide by 10, you decrease. Multiply by 10, you increase your place value. All right, now tell me about number lines. This was the do now from yesterday. Maria plotted point A on the number line below. What is the potential value of point A? Well, we see here, the blue is what I wrote in. So what was given was, this is 4 and 2/10 and 4 and 3/10. That's what was given. So because I see so many dashes or ticks, whatever you want to call the black lines, in between. So I know that it can't be 4.2, 4.3, 4.4. Yeah, that can't be it. Because look, 4.3 is the end goal. I'm trying to find what are the numbers in between 4 and 2/10 and 4 and 3/10. So that's how I know that that each tick mark is going to be 4 and 21 hundredths, 4 and 22 hundredths, until we get, so it goes 20, 21, 22, 23, 24, 25, 26, 27, 28, 29, 30. So I'm trying to figure out what could be the possible value for A. And I look and I see it's in between 4 and 24 hundredths and 4 and 25 hundredths. Well, let's make life easy. If I wanted to do 4 and 24 hundredths times 100, that would become 424. Now, if I did the same thing over here, that would become 425. So if I asked you what is in between 425 and 424, what's in the middle, that might be a bit easier for you to tell me, 420, 424.5. Because you know the middle between 4 and 5 in the middle is 4.5 or 4 and 5/10. Y'all know that. That's easy. But it can be intimidating when we see it as 4 and 24 hundredths and 4 and 25 hundredths. So let's make it a version that we're comfortable with. So 424.5, 424 and 5/10. That would be in the middle. So let's divide that by 100 because we multiply by 100. So let's divide it by 100 to get it back to its original place value. And that would get us with 4 and 245 thousandths. So that's the middle. And the middle, eyeballing, I'm just using my eyes here. The middle between this tick and this tick would be about here. That looks about the middle to me. So I see A is just before the middle. But let's count out. So 1, 2, 3, 4. So if I'm just using my eyes, I can see that A is somewhere. Possible answers are messed up on that one. There we go. Those are possible answers. It needs to be less than 4.245 for 245 thousandths. It needs to be less than that. It needs to be greater than 4 and 24 hundredths and less than 4 and 25 hundredths. It needs to be in that window. On the left side of the halfway point. It needs to be on the left side of the halfway point. So less than the halfway point. So we could do process of elimination. D is the only option that is in the correct zone. So rounding. How do you round decimals? This was in the previous video, so please pause it and read it. The first step is identify the given place value. What is the place value they are wanting us to round to? And in this problem, they say the hundreds. So I go and I identify which number is in the hundreds. 5 is in the ones. This 1 is in the tenths. And 7 is in the hundreds. Great. So that's the number I am looking to round. Well, when I go to the number, that's okay. So 7 is the number I'm rounding, and I need to go to the number to the right and use that one as my reference. So I'm asking myself, is 3 greater than or less than 5? And since 3 is less than 5, we keep the number we're rounding the same. So the finished and rounded product would be 5 and 17/100ths. All right, we played a game, and it's called the Closer To game. And this is a really good way to practice rounding. So, is 456 thousandths closer to 0 or to 1? Well, 0 and 1 are they both have the place value of 1. So they are asking us to round to the nearest 1. So we need to round this entire number to the nearest 1. Well, what number is in the ones place? 0. So I'm going to go to the first place value to the right and use that as my reference point. Well, 4 is less than 5, so the place value that we're rounding stays the same. So 456 thousandths is closer to 0 than it is to 1. Okay, let's go to the next one. Is 456 thousandths closer to 4/10ths or 5/10ths? Well, both 4/10ths and 5/10ths have a place value of tenths. Round to the nearest tenths. So let's go to this. So we are rounding this entire number to the nearest tenths. So which number is in the tenths? The 4. So I go to the first place value or the next place value to the right, which is 5. So is 5 greater than or less than 5? Well, it's 5. So the number in the tenth spot goes up. So this rounded number turns into 5/10ths. So 456 thousandths is closer to 5/10ths than it is 4/10ths. Is 381 thousandths closer to 0 or 1? So we need to round to the ones place. That's the place value you're rounding. 0's in the ones place. I look to 3 because that's the next place value. 3 is less than 5, so 0 stays the same. This rounded number is 0. So it is closer to 0. Now it's asking us, is 381 thousandths closer to 3/10ths or 4/10ths? Well, so we are rounding to the tenths place. What number is in the tenths place? 3. So I go to the right and I use this place value as my reference. 8 is greater than 5, so this becomes 4/10ths. So 381 thousandths is closer to 4/10ths. Is 381 thousandths closer to 38 hundredths or 39 hundredths? These are both in the hundreds place. So that's what I'm rounding to. 3 is in the tenths, 8 is in the hundreds. So I go to the next place value in the right, and I use that as my reference. 1 is less than 5, so 8 stays the same. This rounded number is going to be 38 hundredths. So 381 thousandths is closer to 38 hundredths than it is to 39. Okay, do these last two on your own. Is 95 thousandths closer to 0 or 1? So we are rounding the ones place. I go to the next place value. I see 0. So it is closer to 0. Is 95 thousandths closer to 9 hundredths or 1/10? Ooh, this is tough because these are different place values. What do you think it would be? Well, this was a trick, and look at this. So we are asking ourselves, is it closer to 9 hundredths or 1/10? Well, if we look at the place value to the right, we see it's a 5. So 5 would make the 9 round up, turning this into 1/10. So let's begin. That was a nice little review, a good 17-minute review. I'm sorry that took longer than expected. But let's start with lesson 5 and talking about the powers. So we're going to be doing a lot of practice examples in this video. So by the end of lesson 5, you are going to be able to explain how multiplying by the powers of 10 changes the value of digits in a number. You're also going to understand what does it mean to multiply by the power of 10. 10 to the power of what? What does that do? Scholars will also be able to articulate that multiplying a number by a power of 10 greater than 1 shifts the digit of that number to the left. But multiplying a number by a power of 10 less than 1 shifts the digits of that number to the right. So let's begin. To the powers of 10. So let's start with 1. 10 to the power of 1. What that means is that we are going to multiply 10 by itself once. I know that seems weird and silly, but it will make sense the more examples. I don't know what just happened, but we're back. But I know it seems silly or weird, but it will make more sense the further we go along. So when I do 10 to the power of 2, that is telling me we are going to multiply 10 by itself 2 times. 1, 2. So you can do any number to the power of something to another number. I could do 7 to the power of 2, which would just be 7 times 7. Or I could do 7 to the power of 3, which equals 7 times 7 times 7. But here we're just focusing onto the power of 10. And it's a pretty easy way to do math. And I'll show you why. Because let's move over. We know 10 times 10 equals 100. So we could say 10 to the power of 2 equals 100. So 10 to the power of 2 would just be a quick way to say 100. We also know this as scientific notation. But I'm sure you're thinking, Miss Tharp, it would just be easier to say 100 than 10 to the power of 2. And you're right. This method comes in more, it's more useful when we get into the really big numbers. So let's work our way up there. Or let's just go there right now. I'm spontaneous. I want to do it. So 10 to the power of 9. What does that mean? That means we are going to be multiplying 10 9 times. So let's do that. 1, 2, 3, 4, 5, 6, 7, 8, 9. See, we are multiplying the base by itself 9 times. So 10 is our base. 10 to the power of 9. We are multiplying 10 by itself 9 times. And the answer that we get is not thousand, not million, but billion. 1 billion. And look at this. So 10 to the power of 9 equals 1 billion. So look, a billion has 9 zeros. If you just showed me a billion, I would be able to work backwards. I would be able to figure out, if you just showed me 9 billion and asked me, this is 10 to the power of what? Figure out what power this is to. I could just go 1, 2, 3, 4, 5, 6, 7, 8, 9. 10 to the power of 9. Now, a mistake that many scholars make when first being introduced to 10 to the power of, or to the power of tens, and they are asked, figure out 10 to the power of. What is this? A lot of scholars will use the just add 0 method, because they're told growing up, when you do 10 times 10, you just add a 0. But that's not exactly true. We're not just adding a 0. We are increasing place values. So when we use that logic, when trying to work backwards from 1 billion to figure out it's 10 to the power of what, it could get us into trouble. So don't do this. So what a lot of scholars do is that they think, oh, I'm trying to figure out how many times I multiply 10. And I know it's the just add 0 rule, so I'm going to isolate this 10 and figure out how many zeros I just added. So 1, 2, 3, 4, 5, 6, 7, 8. So the just add 0 rule would give you 10 to the 8th power. Is that correct? It is not. Do not do this, scholars. I repeat, do not do this. Isolating that 10 and just adding the zeros is not going to get you the correct answer. That is why the just add 0 method can be dangerous. You need to consider all the place values involved. So let's do another one. Let's do this one. Equals 10 to the power of what? 1, 2, 3, 4, 5, 6. So I'm going to put my answer as 6. And let's scroll over and see if I'm correct. So I got 1, 2, 3, 4, 5, 6. So far, I'm still checking out. And look at that, 10 to the power of 6. So 10 to the power of 6 is saying I am going to multiply 10 times 10 times 10 times 10 times 10. And if you put that in a calculator or you solved for that, it would be 1 million. 10 to the power of 6. But let's get back to the basics. 10 to the power of 3. That is telling us to multiply 10 3 times. So 10 times 10 times 10. How many zeros is that? 1, 2, 3. 10 to the power of 3. 10 times 10 times 10. Let's do this one and show it all. 1, 2, 3, 4, 5. So I have 100,000, and that equals 10 to the power of 5, which is 10 times 10 times 10 times 10 times 10. So pause this video where it's at right here and make sure you understand what 10 to the power of, or the powers of 10, is asking us to do. Okay. So let's get some practice in. 4 times 10 to the power of 1. What does that equal? That would be the same thing as, let's slow down. What is 10 to the power of 1? That's just 10. So this entire problem is 4 times 10. 40. 10 to the power of 1? 10. If you're lost, go back up here. Remember, if it was 10 to the power of 3, we would be doing 10 times 10 times 10. So I see 1, 2, 3 tens. But I only need 1 10. So 6 times 10, 60. 10 to the power of 1, 10. 30 times 10. We don't just add a 0, we're increasing a place value. 300. 10 to the power of 1, 10. 88 times 10 equals 880. 10 to the power of 1, 10. 53 times 10 equals 530. And we got all those correct. All right. Oh, we're getting tricky now. 6 times 10 to the power of 2. That is telling us to do 10 times 10, which equals 100. So 6 times 100. 10 to the power of 2. 10 times 10, 100. 7 times, messed up there, 100. 10 to the power of 2. 10 times 10 equals 100. Let's pretend this said 10 to the power of 4. That would be 10 times 10 times 10 times 10. And that would equal 10,000. So 55 times 10,000. And let's pretend this said 10 to the power of 3, which equals 10 times 10 times 10. And that equals 1,000. 37 times 1,000. Sorry, I just wanted to get some practice of switching it up a bit. Okay, here now we're doing decimals. This is where it gets fun. All right. 10 to the power of 1. That's where we need to focus on first. And that's just 10, remember? So 2 and 1/10 times 10. Well, since we're multiplying by 10, we are going to move the decimal over 1, which means that is going to equal 21. 10 to the power of 1 equals 10. So 14 and 7/10 times 10. I move the decimal place over 1. So 147. 10 to the power of 2 equals 10 times 10. 100. So 7 47/100ths times 100. I'm going to move the decimal place over 2 places because look, we have 2 zeros. 1, 2. So I'm going to move the decimal place over 2 place values. 1, 2. That answer is going to be 747. 10 to the power of 1, 10. So 5/10 times 10. I move 10 has 1 0. So I'm going to move the decimal over 1 place value in a positive direction. So that is going to end up as 5. 10 to the power of 2. 10 times 10. 8/100ths times 100. So 100 has 2 zeros. So I'm going to move the decimal place over in a positive direction twice. That will equal 8. Last one. 10 to the power of 2. 10 times 10. 99 and 2/10 times 100. So 100 has 2 zeros. When I multiply that, I'm going to move this decimal point over 2 place values. And look, I had to put that 0 there. It was there before, but remember, we usually don't. If it's 99 and 2/10, we don't have to put that 0 there. It's implied. But once we moved the decimal point over, it exposed it and made us make sure we write it down. So our final answer is going to be 9,920. All right, good job, y'all. So let's look at a number string and see if we notice any patterns. Okay, so I have 906 times 1,000. Then I have 906 times 10. Then I have 906 times 1. So what patterns am I noticing? Well, I'm just going to assume. So since the topic of this lesson is powers of 10, I'm going to say 1,000 is 10 to the power of 3. And 10 is 10 to the power of 1. Okay. So do you notice any patterns? How much is the 9 worth in 906? And how much is the 9 worth in 90 and 6/10. What happens when you multiply by the power of 10? When is that not true? So these are some concepts that we are going to explore on our flex day tomorrow. I want y'all to be thinking about this and have it in the back of your mind when you come to class tomorrow. But this is a pretty easy question. How much is the 9 worth in 906? Well, the 9 is in the hundreds place. And in 90 and 6/10, it's in the tens place. And why did that happen? Well, it decreased a place value, so we probably multiplied it. If we do 906 multiplied by 1 over 10 or 1/10, that decimal point that's here would move over here. So I'm assuming that's what happened, but we don't know quite yet. We will find out tomorrow. Practice problem. So we are going to end the video here and do another video of these practice problems tomorrow because we're going to go over these practice problems in class tomorrow. So watch the next video to get these practice problems. Remember, scholars, the most important part of this lesson is this graph. What is the powers of 10? How can we work backwards from it? So how can I figure out 1,000 equals 10 to the power of what? What is it asking? What does it really mean when we say 10 to the power of 3? What does that stand for? Well, that stands for 10 times 10 times 10. Why do we use this? We use it for really big numbers because sometimes when you're multiplying something and you want to say, sometimes it would be a lot easier to just write 10 to the power of 9 times 872. Like if you're a scientist and you're doing some kind of weird mad scientist formula to make a mega Jurassic Park, you would say 10 to the power of 9 times 872 because that would be more efficient than doing 1 billion times 872 because you have to write this over and over and over again. You have to show your work. So sometimes it's more efficient to just write 10 to the power of 9. That's why we use it, to be efficient scientists and mathematicians. So make sure you understand powers of 10 and how when I say 10 to the power of 4, what does that turn into? That turns into 10 times 10 times 10 times 10, which equals 10,000. All right, y'all. So go to the next video to get the practice problems once we do them in class so that you can work through them.